My name is Timshel Purdum, and I am the Director of Playful Learning here at the museum. And I will also be your speaker today. So Lunch Break Science has gone digital for here at the museum. And we're so excited to continue to be able to share this sequence of science talks with you guys. This is presented by Bon Secours each week, and we're very grateful for their support. I have a few folks in the chat that said that they can't hear. If you've accidentally changed the sound settings, the microphone is down to the bottom left in most setups, and you can check your sound settings right there. Go to the microphone and select audio settings if you can't hear. So let's go ahead and get started. Hopefully you guys can all see the Lunch Break Science screen, and I'm going to go ahead and get started. So my name is, again, Ms. Timshel Purdum, and I am the Director of Playful Learning and Inquiry here at the Science Museum, and I also happen to love dinosaurs. And today's talk is Digital Dinosaurs, Fact or Fiction. And you know, my funny little thing right here, science ruined dinosaurs. And I'm here to tell you that it didn't. It's made them all that much better. But I am going to pick on, out of love, some representations of dinosaurs in the past and present. So I am going to pick on a few of my favorite movies of all time and some funny ones in the past. And it is out of love because so much of it is really cool. So how do we go from a bunch of bones in the ground, and this happens to be an image of Dinosaur National Monument in Utah, how do we go from something like that to the way we see dinosaurs in movies and books? So how do we do that? And you'll see in this image some of my my absolute favorite, or sometimes silly, images of dinosaurs from past and present. So how do we get to here? How do we imagine something that we can't see alive on the planet anymore, and all we have is its fossils? How do we bring something like that back to life? So let's start in the background a little bit. They don't come, unlike Jurassic Park might make you believe, all together in one piece. To find a fossil, you actually have to go look for it and do something called prospecting. In this image right here, it's actually, I've been lucky enough to be part of an organization called the Bighorn Basin Paleontological Institute over the last 7 years. And we do research out in Montana and Wyoming looking for dinosaurs. And we spend a lot of time walking around in the desert, in the heat, looking down at the ground. Again, it's called prospecting. And what we're looking for is those little fossils down that you see in the lower corner. Those fossils are those little pieces of rock. In between, there's little pieces of fossilized bone, and that's what you're looking for, because you're going to follow those weird little pieces of bone, hopefully back up to a more complete fossil. You also spend a lot of time licking them. I have licked a lot of rocks in my time. Bone is porous, and even when it fossilizes, it will stick to your tongue using something called capillary action. So I've licked a lot of bones. So after you've found a fossil, you have to get it out of the rock. In this image, across where that white line is, up on top of this hill, dinosaurs aren't always found on the ground. Up on top of this hill is where we found what they're pointing to on the lower image. It's part of a triceratops horn. And we had to climb up that hill. It was rather steep, and remove the really hard sandstone after hauling jackhammers up there to find it and get it out of the rock. And then we had to get it down off the hill. once you get the animal down off the hill, you have to get it out of the field. You might, you take plaster and burlap and even toilet paper actually, and you cover it with plaster to protect it, to get it back out of the field. Those fossils are often heavy. In the top image, they're working on an Allosaurus. In the bottom image, we're working on the tail from a sauropod from Suawasia. And we've had to, I don't know why the sound keeps coming in and out. I am so sorry, guys. We have to wrap them up, load them up onto trucks, and to drive them back to the museums and labs where they're studied. You don't study the dinosaur out in the field. And then once they get back, they're not necessarily all articulated. They're not all one piece. Again, in Jurassic Park, which I love this movie, but they show that dinosaur that's all in one little piece. I'm going to try something else with the sound since folks are still saying that it's not working. I'm going to try one more thing. And I'm going to go back. I'm going to try one more thing if you guys don't mind, because I want to make sure you guys can hear us. I'm going to change what you guys are actually listening to me from. So give me a second.
Okay. How's this? And thank you for my necklace. All right. I've switched off the headset because I think that might have been the problem. All right, so we're gonna do it that way. What you can see in this image is little pieces of fossil bone. They're shattered, and you have to actually glue them all back together. They don't come all in one piece 90% of the time, and you really have to like puzzles. In the lower image is part of that Allosaurus fossil that we found last summer, and it is relatively articulated, put together, but we still have to glue what you see as teeth in that image. So after you've done all of that, and it can take several seasons to get a dinosaur out of the field, then you have to put what you found back together and try to imagine it as a living animal. Oh, and now they said the pictures aren't appearing. We will make sure that happens too. This has been a fun one. Thank you guys for all of your patience. How about that? All right. Yay. So, all right, so the Allosaurus is in that bottom corner. So once we put these things back together, we have to try to understand how they lived. And that started actually about the 1840s. This wonderful looking gentleman that you see in this image here is called Richard Owens. And he was an anatomy professor in England in the 19th century. And this is the man who actually came up with the word dinosaur. And he was so good at knowing what animals looked like under their skin, he was the person that they gave the first dinosaur fossils to try to draw and make them come to life. And the image you see next to him now is called Megalosaurus. And this was the first dinosaur that anybody had ever recreated. And it doesn't look like dinosaurs look like today. It looks very different. And this was drawn by Richard Owen, this man in the picture. And all of those little fossils that you see within his drawing are the only things that were found. And so they reminded him a lot of other types of reptiles, which he knew walked on four legs. So he created it as a four-legged kind of rhinoceros-sized animal. But as we got to find more pieces of fossils, we got a little better understanding. Another really early dinosaur that was described was a dinosaur called Iguanodon, which some of you guys might have seen. It's a pretty famous, well-known dinosaur. And in this image is how they first recreated it. Again, the solid bones are what they had found or what they hadn't found. So they compared it to a rhinoceros iguana. That's who's in this other image. And they thought maybe this just looked like a giant rhinoceros iguana. Now, this was so popular that it kicked off a dinosaur craze that's never really left us, and people trying to recreate them for the public. This image, these crazy looking beasts were built by a scientist, an artist known as Benjamin Waterhouse Hawkins. And these are Iguanodon and Megalosaurus again. And these were out in Hyde Park in London, and people flocked to see these things. And we still do this today. It's still with us. But they still don't look like dinosaurs, do they? So as scientists found more fossils, we moved kind of to North America. The gentleman in this image you see here is Joseph Leidy, and he was probably America's greatest anatomy professor. He was the first person to figure out that some dinosaurs walked on two legs. So we've gone from that four legs on the ground to a vertical looking dinosaur. This dinosaur is called Hadrosaurus foci, and it's a duckbill. And it's still not how we would represent it today, but it was revolutionary to put this animal on its back legs. And this is a dinosaur that was found in New Jersey. And he based it, instead of a rhinoceros iguana, he based it on an animal, a kangaroo. And the kangaroo rests on its tail, and he thought that the dinosaur might be so big that it couldn't stand up on its own, and that it would have to support itself with its tail. And for what it's worth, although this was revolutionary, it influenced dinosaur representation for almost 100 years. By the way, Hadrosaurus foci was the first dinosaur ever mounted at as a skeleton in a museum anywhere in the world. And this image that you see here is called, is a series of different dinosaurs that was done in 1897. And it's a beautiful image by Charles R. Knight, but you can see some of those early influences that are still there. Their tails are on the ground. Doesn't matter whether they've got four legs or two. You've got sauropods in ponds. You've got a duckbill, which is like Hadrosaurus foci with its legs sprawled. But we're moving forward in understanding these as live animals. This image shows them in habitats as live animals, not just individual creatures, but animals that had lives. And so it's definitely moving forward. But again, those tails are down. They've got relatively sprawled legs. They're brown and green still. How did we move forward from this to what we might imagine dinosaurs look like today? Now, as I said before, this influenced how we looked at dinosaurs for almost 100 years. These are some of my favorite goofy, really bad dinosaur movies that go up until the 1980s. Again, we've got brown and gray dinosaurs. We've got tails on the ground. We've got a very interesting looking Ringo Starr for those of us of a certain generation who's getting chewed on by a really weird looking T-Rex. So there's a lot of stuff. It's fun, it's engaging, but there's a lot of stuff wrong. So how did the science change? How did we learn? How did we get to things like Jurassic Park? Well, one of the things that's happened, and in this image you have footprints. One of the things, we're going to start with tail drags and tails. Dinosaurs don't drag their tails. They have all their tails in the early images on the ground because scientists thought that there's no way they could lift these off the ground. And one of the ways that we know that they don't is taking a better look at fossil footprints. And in this image is a couple of different species of dinosaur feet. And one thing you don't see are tail drags. If they had their tails on the ground, in between those tracks would be a line that had been left by the trail. And you don't see that in fossil dinosaur footprints. So that's a really good indication that they didn't drag their tails. Another way we can tell that they didn't drag their tails is the image I just showed. It's the backbone and the back end tail of a duck-billed dinosaur. And the cross-hatched marks are actually ossified tendons. these tendons stiffened the tail and would have prevented it from bending downward and made it mostly moving a side-to-side motion. It gives us the indication that the tails were used for at least some dinosaurs, that would use them as a lever, kind of like a balance beam, so that they would balance across their hips and their legs, so that they could walk around on the two legs, so their tails didn't drag. What else might we still be showing dinosaurs incorrectly and have learned more since certain movies have come out? This happens to be the velociraptors from the first Jurassic Park, which in 1993, I have to admit, was awe-inspiring. It was amazing to see very lifelike dinosaurs on the screen for the first time, but they still have things wrong. And in this image, it says your wrists are broken. And in the circle, you'll notice that its hands are facing so that they're bent up to your arm. Their palms are facing the ground. And don't kid yourselves, you've all pretended to be a dinosaur where your arms just like this, and you pull your arms back and you have your hands like this, the velociraptor in the image, and your palms are facing the ground. But that is not how these types of meat-eating dinosaurs held their hands. In this image, you'll see a dinosaur that's mounted in a museum, and sometimes museums had it wrong. And this Tyrannosaurus Rex in this image, and now you'll see the circle around its arms, they're also facing the ground. That's not correct. Those arms are actually broken. So this mount is even wrong. We know that the hands actually, instead of palms down, were palms facing each other. So if you put your hands where you're getting ready to clap, where your thumb is facing towards the ceiling and your palms are facing each other, that is how these dinosaurs held their arms. Better fossil evidence has let us know that, but also some really neat track fossils as well. The image that you see now is from a dinosaur, a meat-eating dinosaur that sat down. To the right, the drawing, there's a green arrow pointing to something that's labeled LM, and that stands for left manus, or left hand. And what's happening that you see with the feet and that left manus is that dinosaur sat down and balanced itself with its front hand and put its finger and the side of its palm in the ground, which I think is really awesome. It didn't put its palm down, it put the side of the hand. So it's more evidence that they didn't have their hands facing to the ground, but to the side, to facing each other with their palms. How about speed? How fast can these dinosaurs go? Well, in the movie Jurassic Park, one of the things that's a lot of fun is that the T-Rex starts chasing the cars at about 45, 50 miles. Things about science is Jurassic Park, and the author of Jurassic Park, Michael Crichton, did interview a lot of scientists for the movie, but they took a lot of movie license as well, and it actually influenced scientists to do some more digging to figure out how fast T-Rex could actually run. But guess what? His arms are broken. So one of the ways we know that how fast and can estimate how fast a fossil animal can run is by looking at footprints again. You can take the size of the footprint and estimate how tall the animal was, and then you measure the distance between the footprints, and with some mathematical equations, you can figure out how fast the animal was moving. And they've done some really neat experiments comparing it to modern animals and figuring out how fast animals could move. So how did we do that for T-Rex? Well, a number of years ago, a scientist named John Hutchins modeled T-Rex bones in the computer, reattaching where the muscles would have been, which you can tell by scars muscles leave on the bone. So you can tell where the muscles would have been attached in the fossil. And they digitized it and looked at different ways that the T-Rex might have balanced and used those muscles, as well as how much muscle mass it would have needed to be able to run. And then they scaled up a chicken, which I think is hysterical. And they scaled up a chicken because chickens and dinosaurs are very closely related, to figure out how much muscle mass a chicken which they could see the actual muscle mass, would need to be able to run as fast as a T-Rex in the movie. And the chicken would have had to have been 90% muscle mass in each leg. So that would not have all had happened. So it's not possible. So he estimated between 15 and 20 miles an hour with that research. And then just a few years ago, another group of scientists looked at the strength of the bones in a T-Rex to see how strong they would have had to have been to run at certain speeds without breaking. And their estimate brought it down even more to about 10 to 15 miles an hour. So they could certainly run enough to catch dinosaurs for dinner, but they weren't running 50 miles an hour. How about behavior? One of my favorite parts in Jurassic Park is when they're just seeing the dinosaurs and he's getting he's getting things confirmed that he'd always wondered. But how do we understand behavior when we can't see this animal alive, right? Again, how do we see this for extinct? So again, one of the ways that we understand how animals behave when we can't see them alive is to look at their fossil footprints. I'm going to take a moment right now. A lot of folks have mentioned to turn off the chat. You can actually hide your chat if you want to. So it'll flash at you, unfortunately, but you don't have to. You can make the Zoom full screen and the chat will go away to the side. So you can actually minimize the chat. So in this image, the trackways that you are seeing, one of the things that they're showing is dinosaur behavior. The giant footprints in the top image, which is a drawing, are from sauropods, those long-necked dinosaurs. Those long-necked dinosaurs, there's been some estimate that maybe they moved in herds. Well, this was a trackway in Texas that's given us an idea that maybe they did. There's large giant sauropod footprints and smaller juvenile sauropod footprints. And the large footprints have been stepped on by the juvenile footprints. And they all seem to have been laid down at the same time. One of the cool things about that tells us is that they were all working together to move. Now, whether they herded all the time or this was a special seasonal thing, we're not sure, but they were all definitely in the same area walking across a muddy spot. So that's a really cool. The image you see in this picture is from a site that I've been working on with the Bighorn Basin Paleo Group. The fossils in this image are of Diplodocus. These are large sauropods again. And one of the cool things about this site, it's called the Mother's Day site. And it's been worked on for a number of years. And one of the really cool things about this site is that all we have found is really small Diplodocus. They're all the same size and they're all little. And initially, the scientists thought that they might have been dwarfs. And we do have evidence of fossil dinosaurs that were dwarfs from areas in Romania, but it's looking more likely that the Diplodocus from the site that I've been working on are all juveniles and that they all died at around the same time. So it's really kind of interesting. So again, it seems like that at least at some points in their lives, these animals did all hang out and live together. How about pack hunting? Velociraptor in the movie Jurassic Park is shown as an animal that works together collaboratively, being very smart to bring other dinosaurs down. Well, did they do that? Well, Jurassic Park got a lot of things wrong about these dinosaurs, sort of on purpose. So we're going to talk about that a little bit. right before Jurassic Park came out, and then a number of years before Jurassic Park came out, and when Michael Crichton was writing the book, he talked to a dinosaur expert named John Ostrom. And this gentleman was an amazing dinosaur paleontologist, and he is the one who discovered the animals in this picture and described an animal called Deinonychus, which is a type of raptor, kind of like Velociraptor. And he had found a site where they were 4 different individuals were found associated with the bones of the animal you see here called Tenontosaur that had been eaten, partially eaten by the Deinonychus. And it made him think, among other things, that these animals might have worked together to eat that dinosaur, because there were at least 4 individuals, that they may have worked together to bring it down and to hunt it. But there's another explanation for this. It could have been behavior like the Komodo dragons you see in the lower image. These Komodo dragons do not hunt together, but they will eat together. These dragons, once something's dead, they will all converge on it and start eating. And that is a perfectly logical explanation for the raptors that Dr. Ostrom found as well. So more recently than that, there have been some other really interesting research on the raptors and whether they worked together in groups. The top image is a series of footprints from China where we've got at least 4 individual raptors walking across a muddy bank at the same time. So again, it doesn't tell us if they were hunting together, but it does indicate that they were at least together to a certain extent. The bottom image is research that actually just got in the press within the last week and will be published in August. And it was actually looking at the isotope ratios in the teeth of these raptorian dinosaurs. And different isotopes are embedded in the teeth depending on what you're eating. And what it led them to determine is that young Deinonychus ate different foods than adult Deinonychus, which tells us that at the very least, adults and juveniles were eating different foods and not working together to bring down prey. And that's not typical of animals that are pack hunters that we know of today. So it sounds like that they probably didn't hunt in packs as of this week. All right, what more can we dig into Velociraptor and Jurassic Park? Another thing that I love Jurassic Park, but that we can quibble with is that none of the dinosaurs in Jurassic Park have feathers. And to be fair, in 1993, it wasn't really a thing. It was something that we knew that they were related to birds, and that's even mentioned in the movie as a theory. But the feather thing was still to be discovered, if you will. So how many feathers did they have? Well, interestingly enough, even though at the time of Jurassic Park, they didn't have feathers in any of the dinosaurs, we knew that there were animals that had feathers that looked a lot like dinosaurs. And this is an image of Archaeopteryx. It happens to be the only specimen in the United States that is in Wyoming in Thermopolis. And I actually took this picture because I geeked out about it. And this was discovered again around the same time as the rest of the dinosaurs. And so we knew that there were animals that looked very reptile-like, long tails and teeth, but that had feathers. But how closely they related to dinosaurs and birds, what was that link, really hadn't been thoroughly explored until much more recently. So how did we move from dinosaurs might have be related to birds to birds are dinosaurs? This image again is Deinonychus. And John Ostrom, that same scientist that we met before, when he discovered Deinonychus or described Deinonychus, one of the really amazing things is that he noticed in its skeleton was that it had a lot of bone parts that were related to birds, including its pelvis, which is shaped like a bird's. They have a wishbone, just like a turkey has. And they also have a bone in their wrist, which the image that you see now is with the arrows pointing to it, called a semilunate carpal. And that bone where those arrows are pointing, those images that you see are Deinonychus's arm and an Archaeopteryx arm. And if I had a chicken arm to show it would show it too. That bone allows them to pull their arms back and reach out and grab their prey. So it's a bone that showed up in animals like Deinonychus, and that was co-opted by birds later to be able to fly. So there were all these similarities between these animals and birds. So were they birds? Were they feathered? Well, the fun thing is that after Jurassic Park came out, lots of wonderful, beautiful fossils like the ones you see here came out. It started to come out of China. And the animals you see here in the lower left is a little dinosaur called Sinosauropteryx. The top one is a Microraptor. And there's even a dinosaur tail that was discovered relatively recently that is covered with feathers that was found in amber. So these fossils are incredible. And it's not just things like Archaeopteryx. It's all sorts of dinosaurs that are just covered with feathers, where we've had the fossilization to help understand, leave the feather imprints. I see a question that says, what is a wishbone? And that's a really good question. So if you've ever had a turkey dinner and at Thanksgiving, you pull something that looks like kind of like a Y-shaped bone apart to wish good luck, that's actually the turkey's wishbone. And what it is it's the same bone that you kind of have a pre-wishbone, if you will. You have clavicles. Those are two bones that are right up on the top of your chest. And in a bird and in these dinosaurs, it's fused in the middle. So we know that these dinosaurs have feathers. Lots of dinosaurs have feathers. And it's not, almost all of the meat-eating dinosaurs seem to, the more we find, have feathers. And we're even finding dinosaurs that have feathers that we didn't expect to have feathers. Well, what about the raptors? And this is blue from the Jurassic World images. And oh, by the way, look at those hands. The dinosaurs in Jurassic Park and Jurassic World still don't have feathers. And in some respects, Steven Spielberg has decided to keep it that way. He wants to keep the look of the movies, and I can understand that. But we've never found a fossil of a velociraptor or a Deinonychus with feathers. So how do I know whether or not Velociraptor and its cousins had feathers? Well, interestingly enough, in 2007, this great little paper came out. And in the image you see here, the images C, D, E, and F are of goose and swan front arms, their ulnas, dissected. And it's where the wing feathers are attached on that ulna. Those feathers leave imprints in the bone. And at the top, letters A and B are a fossil Velociraptor ulna, that same bone you see in the goose. And those dots you see along the ulna are the imprints of quill knobs, those feather imprints. So although we don't have feather prints in the fossil, there's evidence on the arm of the Velociraptor that shows that it had feathers attached to its arms. It's got quill knobs. So a better way of showing Velociraptor would be this: covered in feathers, wing-type feathers along its front arms, still dangerous and gonna eat you. And again, the arms are broken in the Jurassic Park movies, but it's okay. So we know that the raptors had feathers. What about T-Rex? Oh, as an aside, just so you know, the image you see here where the green arrow is pointing, that's Deinonychus. It's a pretty decent sized animal. And you can see compared to the human, that's about the size of the ones in Jurassic Park. And Michael Crichton had talked to Dr. Ostrom about Deinonychus. The next arrow is actually pointing to Velociraptor, which is much more closer in size to a turkey, much smaller than they are in the movie. And the biggest raptor you see in the middle is Utah raptor, which is one of the largest raptors, and is bigger than the ones you see in the movie, but is kind of scary. So what about T-Rex? Well, we do have fossils of T-Rex skin. This is an image of the scales that would have covered a T-Rex. So we know that at least part of their body had scales. But in recent years, we've started to have fossils that, again, coming out of China, of Tyrannosaurus rex cousins that are covered with feathers. And those feathers animals, like this one, which is Eutyrannus, they're really closely related to T-Rex. And we have absolute evidence from their fossils that they had feathers. So it gives us the indication that T-Rex might have had T-Rex might have had feathers at some point in its life. Is it as fluffy as the one you see in this image? Probably not. But it's very possible that Tyrannosaurus rex might have had feathers on some parts of its body. All right. I can't leave this talk without talking about color, because as a person who loves dinosaurs and teaches about dinosaurs and studies dinosaurs, until recently, we always just assumed that because fossils' skin imprints are just the color of the rock that they're found in, that we'd never know what color the dinosaurs were. But finding the fossil feathers has given us an opportunity to learn more about the dinosaur colors, at least for some species. So the little dinosaur in the drawing you see here at the bottom is Sinosauropteryx. We met him earlier. He was the first one with fossil feathers described. And the one at the top is Anchiornis. And the colors that they've been created here are actually based on cells that have been found in the feathers of these actual dinosaurs. The scientists began to look under high magnification at the feathers of the fossils that we'd found, and they found these different structures in the feathers that reminded them of the exact same structures that were seen in actual feathers of modern birds. And they're called melanosomes, and they hold the pigments of the cell's color. So your hair has melanosomes in it. And in birds, browns, reds, blacks hold that color in these melanosomes, and they found these in the fossil dinosaurs. And the shape of the melanosome is related to the color that it holds. So the oblongs are reds, the rounder ones are blacks. And they use that information to reconstruct the colors in the two you see here. Now, we can't figure out things like structural colors, colors like blues, which tend to come from the shape of the feathers themselves. But it does get us closer than ever to understanding what dinosaurs might have been like in technicolor, if you will. And we've gotten pretty good at this technology so that we've been able to look at other types of dinosaurs that didn't have feathers. This is a beautiful dinosaur out of Canada called Boreala peltus. And it has really well-preserved skin structure. And on that skin structure, we've been able to look at it under the microscope and understand that this dinosaur was probably reddish, and which I think is really awesome. This is a gorgeous specimen. I hope that I can be able to see it one day. Now, did dinosaurs look like this? And this happens to be from, is a great paleo artist named Chris DiPiazza. And this is Hadrosaurus foci, that dinosaur from the beginning. And this is his interpretation of what it might look like. Was it this colorful? Probably not. But it's wonderful to live in a time where dinosaurs not only are more accurate in how they lived and how they moved, but also how they looked. But also, we're still learning, and we still get to be creative. And in fact, one of the reasons that I love paleontology and dinosaurs so much is that they represent how science works. It's kind of a gateway, because science isn't a series of memorized facts. Science changes as we learn more. Our understanding about how dinosaurs lived has changed drastically in 150 years. And all science does that. And I think it's always a good reminder, even to scientists, that as we learn more, as we study more, as we develop new technologies to learn about our world, our understanding of that world changes as well. So I'm happy to ask questions, answer questions. I know somebody asked what Technicolor is, and that's an old term for all the different, when movies first became color, how we, it's just a technology used to color the movies. So that's an absolute good question. So if there's
I've got a few other notes in here. I'd love
Absolutely.
to have you answer some questions. Thank you, everyone. Please continue to put your questions in the chat bar if you have direct questions that you would like to ask of Timshel. I'm going to go through a few. One of them came up about the color and about Blue from Jurassic World. And she was a female and they represented her with that color. What about the difference between male versus female and their coloring? Do you have any information you can share about that?
Actually, that's a really good question. We don't actually know how to differentiate, just like modern birds, right? So you're right. Sometimes female dinosaurs and, female birds, well, birds are dinosaurs. So anyway, it'll make you think of your chicken dinner differently. Many birds today have different colors for a male and a female, or different feather shapes. So you can imagine a male peacock looks very different than a female peacock, or a male cardinal looks very different than a female cardinal. So can we tell that for dinosaurs? Well, we haven't been able to do it for color, but we do have some wonderful dinosaurs. There's a little dinosaur called Confucius ornis. That's a fun name. And we actually have fossils of male and females where the males have really long tail feathers and the females do not. And the reason we know that the female didn't have the feathers is one of the female fossils has an egg inside her. So it's just so amazing. So we have the female with an egg, definitely has to have been the girl. And then she's in the same fossil layer right next to her is a male, same animal with long tail. So it's one dinosaur, at least we know male and female look different. Real quickly, another way that we're able to tell, at least for some dinosaurs, whether they're male and female, and we've been able to do this with a tyrannosaur, is birds have something called medullary bone. And it is a bone where the female starts storing calcium in her leg prior to laying eggs, because she needs to be able to pull that calcium out to lay the egg. And it looks differently than the rest of her bone. Now, it doesn't always exist. It's only right before egg laying. But we've been lucky enough, and at least a few dinosaurs, including one T-Rex specimen, that we've looked at their internal structure of their bone, and we found this medullary bone. So at least for these few specimens, they were getting ready to lay eggs, and we know those were females. Excellent question.
Awesome. And we've got some question about teeth. So how many teeth do dinosaurs have? Does that vary per type of dinosaur? And are T-Rex teeth the size of bananas?
All good questions. So T-Rex teeth were absolutely large. I've gotten to hold some in my career. And yes, the entire tooth was the size of a banana, but most of that wasn't exposed. Half of that is the root, just like your teeth has a root and it was in the animal's jaw. So to numbers of teeth, just like with modern reptiles or modern mammals, the number of teeth in a dinosaur would vary depending on the type of dinosaur. The dinosaurs with the most teeth, and maybe the most teeth of any animals that ever lived, were those duck-billed dinosaurs like hadrosaurs. They could have had up to 2,000 teeth in their mouth at any one time. But another cool thing about most dinosaurs is that they were also like sharks. They continuously lost and grew new teeth, and they were always replaced, which I think is pretty neat. So they were always in the process of having a full tooth, a full set of teeth, unlike, say, humans who only have 2 sets of teeth. I did see a couple people have asked what my favorite dinosaur is, and it actually happens to be a duck-billed dinosaur called Parasaurolophus, which is the one with the really long tube across the top of its head. And evidence suggests that they used that long tube-shaped structure, which was connected to its nose, as a sound-making device. Jennifer, I also see a lot of people asking about Spinosaurus. Which I have to answer because, you know, that's been in the news a lot lately. And we've been sharing some news about Spinosaurus. And Spinosaurus was in the third Jurassic Park movie. So evidence has been mounting that Spinosaurus might be an aquatic dinosaur. It's very intriguing. I think we still need more evidence, but it does show us how the limited fossils that we used to have of Spinosaurus actually were kept in Germany. And during World War II, those fossils that museum was bombed and those fossils were destroyed. So we've been looking for other additional Spinosaurus fossils since the 1940s. And in the past few years, the team that published the research that is out right now has found more specimens, which is fantastic. And the most recent research looks at their tail. We've got a much more complete tail, and it doesn't look like any dinosaur tail that we've seen before, and it's got long processes on the tail off the vertebrae that looks very similar to what we might see in a modern crocodile or alligator. So it's good in strong evidence that this animal was aquatic to a certain extent. Now we're talking about a 50-foot long animal. It's bigger than T-Rex, and we still haven't explained what that big sail on its back is. So there's more work to be done. But again, that's why it's so much fun to be intrigued by paleontology, because as we learn more, we discover more. What else,
Great.
Jennifer?
So how many different types of dinosaurs are there?
We've described scientifically almost 1,000 species, but just like anything else, some of those species in the scientific world we call it lumping and splitting. Some scientists think they should all be shrunk down to fewer when you're looking at a fossil, and some scientists want to split them into even more types based on subtle differences. So the number fluctuates. Until recently, as an example, we had 3 dinosaurs. One was Pachycephalosaurus, which is one of the head-butting ones, Stygimoloch, another Pachycephalosaur, and Dracorex. And they were listed as 3 different dinosaurs. And when the last few years, scientists have currently made them into one dinosaur again at different phases of their life cycle. So it's kind of fun as you find fossils, whether they're all different animals or are they all variations on a theme. Because, right, even animals, if you go out and you look at all the different types of, even one cardinal looks different from the next cardinal.
Gotcha. We've got some questions about the size of dinosaurs. Some people have said things like certain types are the size of a chicken, or how big is this dinosaur compared to a person? So maybe you could just do a quick range of maybe the smallest to the largest that we know of.
Yeah, absolutely. Well, the smallest, to be perfectly accurate, is the bee hummingbird that lives in Cuba, because it is the smallest bird, which means it's also the smallest dinosaur that's ever lived. But I know that's not what you really want to know. Some of the smallest dinosaurs ever discovered are things around the size of a chicken, at least as far as extinct ones, things like Compsognathus, or Yichi, which is a little feathered dinosaur that, chicken sized, between chicken and turkey. Some of the largest are the sauropods, again, those long necked dinosaurs. And every scientist who finds a big dinosaur wants it to be bigger than the one that was found previously. But since they're all fragmented and we don't often have, in fact, I don't think there is a single sauropod where we have the entire skeleton, all of those sizes you see as this one's bigger are estimates. So, the biggest ones we know that were around 100 feet long, about the size of a blue whale, but some of the numbers you see higher than that are really guesses and may not be based on accurate numbers.
Great. What about your recommendations for some must-see displays in museums related to dinosaurs all across the world? Are there any places that you have just been awed, or places that people should put on their visit list when we're able to travel again?
I think that's a really good question. And I would love to go to all of the places and I have a big bucket list. In the United States, once they reopen, I definitely want to put a plug out for the Smithsonian Museum of Natural History, because they just opened their new dinosaur hall, and their paleontology hall called Deep Time. And I had the pleasure of taking a tour while they were building it, and it's a really great display. So you should definitely go see it. The American Museum of Natural History in New York also has a beautiful hall. Canada, at the Royal Tyrrell Museum and the Royal Ontario both have beautiful dinosaur halls. And if you want to see it's just hard to pick one. The Wyoming Dinosaur Center in Thermopolis also lets you go out and dig dinosaurs behind their museum, which is way cool. And they are the ones that have the only specimen of Archaeopteryx in North America. So that's totally worth it. And the field. Oh, how can I forget the Field Museum? Absolutely. Somebody just posted that. Yeah, because in addition to all of their really amazing dinosaurs, they also have Sue the T-Rex, which is one of the most complete T-Rexes ever found.
Great. And then I'm going to combine one to make this our last question before we let you sign off. We got some questions about claws and the purpose of the claw on the Velociraptor, or whether toe claws really stick straight up on some of the dinosaurs. Can you talk a little bit about those claws before we head out for the day?
Yeah, absolutely. And I didn't talk about it when I had the image up, but at least for the raptors, so it's their second toe. In the movies, it's hard to tell, but they have it kind of right. It's the second toe on their feet, but that first toe of those dinosaurs, and this includes T-Rex, is very short and very small, so it's hard to see. That toe, that's claw, we know they held it up off the ground when they're walking, because those trackways that we have of those dinosaurs, of the raptors, there's only 2 toes. So instead of the typical 3 that we see with other meat-eating dinosaurs, you only have the 2 toes that are touching the ground and leaving the track. So we know they held them up. Did they jump up and fly through the air and attack dinosaurs and then rip them to shreds with their claws? Probably not. There's some fun research looking at the mechanics of how those claws and those legs worked, and they probably weren't capable of ripping, but they certainly could have been used to hold prey down like modern birds of prey do, and to keep them from struggling, if you will. All right,
great.
So I want to thank everybody for coming today. I certainly apologize for some of the technical difficulties that we had at the beginning, but it is one of my favorite subjects, and I'm glad that you could join us for Lunch Break Science. Please stay safe, healthy, and for more content, join us at smv.org/stay connected, and that's where we'll be posting today's dinosaur lunch break science as well. Thank you, guys. Bye now.